Hello everyone. For this lesson, I'll show you how to find the resultant vector between two vectors when the angle between them is an obtuse angle. Again, do not assume that the original question is drawn to scale unless it's stated otherwise. And very similarly, like the one with the acute angle, you first start off by selecting the appropriate scale. And it can only be done by elimination. So I start off by 1:1, 1 cm represents 1 Newton, and you cannot draw 4200 cm on this paper. And you start to go down the line slowly. So 1:10, 1:100, and 1:1000. And when you reach 1000, you find that perhaps the diagram will be too small because it's 4.2 cm for the longest vector. So you decide to settle for 1:500. So 1 cm represents 500 newtons. Again, you will not know whether this is suitable or not. You just proceed and try first. If it does not, you have to erase your diagram and find another suitable scale. And that's why it's important to draw with a 2B pencil and a soft eraser. And what I've shown here is I first draw the 3400 newtons vector, and notice I draw a long line. I draw a line longer than 6.8 cm, right? And then mark out 6.8 cm. Remember, if the line is long, you can always erase it, but if it's short, you can't erase, you can't extend it accurately. So better draw a long line first. And remember to mark out the vector with an arrow. And once I've drawn the 3400 newtons, I have to mark out the 150 degrees angle. Right, I'm now going to draw the 4200 newtons, and it's represented by 8.4 cm. Right, there's not enough space on my table here, so I'm starting my length from 10 cm, not 0 cm, right? So yes, I'm still drawing 8.4 cm. So I'm going to mark out the 8.4 cm, and this line will represent 4200 newtons. And likewise, I put my length in bracket and my force, I'm just write out the force without the bracket. Right, so this will provide more clarity for me when I try to solve the problem. I mark out 150 degrees. After that, recall your parallelogram method. Right, so you're going to complete the parallelogram. Using the set square and a ruler, you're now going to complete the parallelogram. Okay, there's a slight adjustment, and notice how I go back and find a original position first. And then, now I'm trying to locate the parallel side of the 4200 newtons. And notice, I just try to draw as long a line as possible. Okay, just try to draw as long a line as possible. As I say, you can always erase the line later. Okay, now I'm trying to draw the parallel side to 3400 newtons. Okay, and the resultant vector should lie in between 3,400 newtons, and 4,200 newtons. And notice I draw a faint line outside the vector, right? Because I'm worried that my protractor will be bigger than this line. Okay, so that will help me locate the angle and represent the resultant vector with a double arrow. Okay, now I'm measuring the length of the resultant vector, and that gives me 4.3 cm. Right now I'm trying to locate the direction, which is the angle between 3,400 newtons and the resultant vector. Now you can always measure the angle between 4,200 newtons and the resultant vector too. Right, so the angle actually gives you the direction of the resultant vector. So you don't have to worry which angle you measure, just measure one of them. Right, so for me, 3,400 and resultant vector, so what I have is 95 degrees. Okay, and once I have the information, I now calculate the resultant vector. So I have 4.3 centimeters, I multiply it by 500 because my scale is 1 cm represent 500 newtons. So if it's 4.3 cm, I'll just multiply by 500. That'll give me 2,150 newtons. And always make it a habit to annotate back in the vector diagram. And the angle between 3,400 newtons and 2,150 newton is actually the direction of the resultant vector. So you just measure the angle and you get the direction.